Hello everyone. On this video we will be covering the fundamental theorem of calculus. Okay, so the fundamental theorem of calculus basically states if some function that we'll call f of x is continuous over some closed interval from a to b, and our uppercase f of x is our antiderivative, then the integral from a to b of our function of x with respect to x is equal to the antiderivative of our b value minus the antiderivative of our a value. Okay, so let's put that into action. Okay, so what if we wanted to find the integral from -3 to -1 of x to the fourth power with respect to x? All right, so for this one, you want to remember your antiderivative of x to the power of some number n, real number, with respect to x, is equal to x to the n plus 1 divided by n plus 1 plus c. Okay? Now, the plus c is important, but when you're using the fundamental theorem of calculus, you don't need to add the plus c, and I'll show you why after we solve the problem. Okay, so you have the integral from -3 to -1 of x to the fourth with respect to x, and using the integral formula here, that's going to equal x to the fourth power, so we're going to add that, so we have x to the fourth plus 1 divided by 4 plus 1. And that's over the, let me clean that up a little. And that's from the integral from, the interval from -3 to -1. So we'll put the -3 to -1. Okay, so if we simplify this, this just becomes x to the fifth power divided by 5 from -3 to -1. Okay, so this is our integral. This is our uppercase f of x, x over 5 over 5. Now, what we're going to do is, remember, you have your a, which in this case is your a, and this is your b. You're going to plug in your b first. So that's going to equal, your b is equal to -1, so you have -1 to the fifth divided by 5. Oh, let me move that up some more. Minus what you get when you plug in your a. So that would be -3 to the fifth divided by 5. So this is your f of b. This is your uppercase f of a. Okay, so if we go ahead and simplify that the rest of the way, that's going to equal -1 to the fifth power is just -1. So you have -1 over 5 minus -3 to the fifth power is actually just -243 over 5, which is equal to 242 over 5. All right, so that's how you would use the fundamental theorem of calculus. Okay, so if you are still writing, feel free to press pause, But now I'm going to show you why we didn't need to add the plus c. Okay, so just use that as a note. No plus c is necessary when using the fundamental theorem of calculus. Okay, and let me show you why. So in the previous problem, when we won't start at the very beginning, but we had x to the fifth over 5 as our integral. So what if we had x to the fifth over 5 plus c from -3 to -1? Okay, so we're just going to plug in our -1 first. And when we did that, we already know we ended up with -1 to the fifth. So if we plug in our -1 to the fifth power is -1. So you have -1, not to the fifth, but -1 over 5 plus c minus, if we plug in our -3, we ended up with -243. -243 over 5 plus c. So when we distribute that negative, we would end up with -1/5 plus c plus 243 over 5 minus c. So the plus c and minus c will always cancel each other out when you use the fundamental theorem. So that's why you didn't have to add it. Okay, so you end up with 242 over 5 no matter what. Okay, so since we know they're going to cancel each other out when we use the fundamental theorem, just don't add it. I mean, you can, but it's just a little extra work for you. All right, so if you are still writing this, feel free to press pause, but we're going to go ahead and move on to our next example. All right, so let's say if we have for this example, say we have the integral from 1 to 4 of 5t to the 3/2 power minus 9 with respect to t. Okay, so once again, we're going to remember that the integral of x to the nth power with respect to x, and works with x or t or s or anything else, equals x to the n plus 1 over n plus 1 plus c. But because we actually have a definite integral, we have actual values here, we don't need the plus c. Okay, so we're going to go ahead and just rewrite that. But we're going to go ahead and distribute that. So you have the integral from 1 to 4 of 5t to the 3/2 power with respect to t minus the integral from 1 to 4 of 9 with respect to t. All right, so if we integrate both of these, we can bring our 5 to the outside, so we have our integral of t to the 3/2, so that's t to the 3/2 plus 1 over 3/2 plus 1. And that is from 1 to 4 minus the integral of just a constant 9 will end up being 9t. And I'll show you why. So 9, remember anything raised to the 0 power is just 1, so we can make that 9x times x to the 0 power if we wanted to. So if you take the integral of this, well in this case t, so let me write the t so it's a little less confusing, t to the 0 power. So if we take the integral of this, remember you're raising that t to the 0 power and you're adding 1. So the integral of 9 would just be 9 t to the 0 plus 1 over 0 plus 1, which is just 9t. So that's why the integral of 9 is just 9t. Okay, so we have 9t, and that's from 1 to 4. Okay, now if you wanted to, you didn't have to separate these. You could have left it like this and have them all together from 1 to 4. Completely up to you. Okay, so since these are both from 1 to 4, you can just put them back together, or you can have them separate. Doesn't matter at all, whichever way you're comfortable with. Okay, so if we make that 1 equal to 2 over 2, we have 3 over 2 plus 2 over 2, which is 5 over 2. So we have 5 times, and if you want to use a closed bracket there, you can, t to the 5 over 2 over 5 over 2. And again, that's from 1 to 4 minus, and 9t is just 9t, from 1 to 4. Okay, so if you multiply the numerator and denominator by the reciprocal of your denominator, so if you multiply this by 2 over 5 and 2 over 5, we end up with 5 times 2 over 5, t to the 5 over 2 power, from 1 to 4, minus 9t, from 1 to 4. These two 5s will cancel each other out. So you have 2t to the 5/2 power. Again, from 1 to 4, minus 9t from 1 to 4. So just kind of simplify that. All right. So I'm just going to go ahead and rewrite t to the 5/2 power is just equal to the square root of t to the 5th power. So you can rewrite that just to make it a little easier to work with. So square root of t to the 5th power. All right. So now we can go ahead and start plugging in our values. Okay, so first we plug in our 4. So 2 times square root of 4 to the 5th power minus 2, then we plug in our 1, square root of 1 to the 5th power. Okay, so that's minus, now we do the same thing here. 9 times 4 minus 9 times 1. Okay, so if we go ahead and simplify these, this is 2, square root of 4 is 2, 2 to the 5th power is 32, so you have 2 times 32, minus, square root of 1 is 1, 1 to the 5th power is just 1, so that's just 2 times 1. 9 times 4 is 36, minus 9 times 1, which is just 9. Okay, so 2 times 32 is 64, minus 2 is 62, minus 36 minus 9 is 27, which is 35. All right, so if you are still writing, feel free to press pause, but we're going to go ahead and move on to our next example. All right, so for this example, what if we wanted to find the integral from -3 to -1, make that negative a little bigger, of t to the third power plus 6t squared plus 9t plus 9 with respect to t. All right. So what I want you to do is I want you to go ahead and press pause and try to work this one out on your own. All right, so assuming you've pressed pause and you've already worked this one out, you can go ahead and verify your answer. Okay, so what we're going to do is we're just going to go ahead and leave it like this. We're not going to separate it into different integrals like we did before on the previous example. We're just going to solve each individual term. Okay, so once again, we know that the integral of t to the third, and I'll just go ahead and rewrite it. I just have a better feeling when I rewrite it. 6t squared plus 9t plus 9 with respect to t. Okay, so the integral of t to the third is just t to the 3 plus 1 over 3 plus 1 plus 6 times the integral of t squared is t to the 2 plus 1 over 2 plus 1 plus 9 times the integral of t. Remember, that's just t to the first power, so you have t to the 1 plus 1 over 1 plus 1 plus the integral of a constant is just, in this case, 9t. And that's from -3 to -1. All right, so if we go ahead and simplify this, t to the 3 plus 1 is just t to the fourth power. So you have t to the fourth power divided by 3 plus 1. That's just t to the fourth power over 4, or you can just bring that out and make it 1/4 t to the fourth power. Either way works. Okay, so that's plus t to the 2 plus 1 power is just t to the third power. Divided by 2 plus 1 is 3. So 6 divided by 3 will just give us 2. Okay. Plus t to the 1 plus 1 power is just t squared. Divided by 1 plus 1 is 2. So that's 9 times t squared over 2, we can just bring that 2 in the denominator over, and we just make that 9 over 2. Plus, and 9t is just 9t. Don't really need to do too much to that one. And that's from -3 to -1. All right. So now, we're going to plug in our b value first. We have 1 over 4 times -1 to the fourth plus 2 times -1 to the third plus 9 over 2 times -1 squared plus 9 times -1. Okay, so we plugged in our b value into our integrals. So now we subtract and we plug in our a value to the very same integrals. Okay, so you have 1 over 4 times -3 to the fourth plus 2 times -3 to the third plus 9 over 2 times -3 squared plus 9 times -3. Uh-oh, almost ran out of room here. There we go. That's better. All right, so as we can see here, -1 to the fourth power is just 1. So we end up with 1/4 Negative 1 to the third power is negative 1. 2 times negative 1 is negative 2, so we can just make that our minus 2. Negative 1 squared is positive 1, so that's 9 over 2 times 1 is just 9 over 2. Minus 9 times negative 1, of course, is negative, so that makes that minus 9. Okay, minus negative 3 to the fourth power is positive 81. So you have 1/4 times 81 plus, well, actually this would become minus, because negative 3 to the third power is negative 27. Negative 27 times 2 is negative 54. Okay, so negative 3 squared is positive 9. So that would give you 9 times 9, which is 81 over 2. And 9 times negative 3 is negative 27. So that would be our minus 27. Okay, so we're going to go ahead and simplify these a little bit. In order to add these two, I'm going to go ahead and multiply this by 2 over 2. And just kind of... Okay, so you have 1/4 plus 18 over 4, which is 19 over 4. And then when we go ahead and add these two together, we have minus 11. Minus, you have 81 over 4. Minus, go ahead and combine these two. Instead of minus 54, we can make that minus 81 plus 81 over 2. Okay. So again, we go ahead and combine these terms, but we're going to kind of skip all of those steps. So we make this 44 over 4, combine those like terms, and we end up with negative 25 over 4 minus negative 81 over 4. Which of course is our negative 25 plus 81 over 4, which is equal to 14, once you simplify it. All right. So if you are still writing this down, by all means, feel free to press pause. But we're going to go ahead and move on to our next example. Okay, and this one is just in case you have a square root in the denominator. So you have 4 to 9. So you have 3x minus 4 over square root of x with respect to x. Okay, so if you're given that little odd square root in the denominator and you want to find the integral for it using the fundamental theorem, or the definite integral. All right. So the first thing we're going to do is we're going to go ahead and separate those two. So you have the integral from 4 to 9 of 3x minus 4 over square root of x with respect to x. That is going to equal the integral from 4 to 9 of 3x over square root of x minus 4 over square root of x with respect to x. Okay, so all I did was just separate those into two fractions. All right, so now if you remember, square root of x is just x to the 1/2 power. Okay, so that means, I'm just going to move this over a little bit. It's going to equal the integral from 4 to 9 of 3x over x to the 1/2 power minus 4 over x to the 1/2 power with respect to x. Okay, so now, if you remember your exponent laws, x to the m over x to the n equals x to the m minus n. So that means x to the first power minus x to the 1/2 power is going to be 3 times x to the 1 minus 1/2, which is just x to the positive 1/2. Minus, instead of 4 over x to the 1/2 power, we can bring that exponent in the denominator up by making it negative. So it's 4x to the negative 1/2 power with respect to x. Okay, so just using our basic exponent rules, we were able to turn this function with a square root in the denominator into this that's a little easier to integrate. All right, so we're going to go ahead and integrate both of those. I'm just going to move that over a little bit. So this will become the integral of x to the 1/2, so that's 3 times x to the 1/2 plus 1 over 1/2 plus 1 minus 4 times x to the negative 1/2 plus 1 over, let me make that a little bigger, negative 1/2 plus 1. And that is from the interval from 4 to 9. All right, so let's go ahead and simplify those terms a little bit. You can put double brackets if you like. Okay, so that's 3 times, you have x to the 1/2 plus 1. If we make that 1 equal to 2 over 2, you have 1 over 2 plus 2 over 2, which is 3 over 2. So you have 3 times x to the 3/2 power over 3/2 minus 4 times x to the negative 1/2 plus 1 is just positive 1/2. So you have 4 times x to the 1/2 power over 1/2. And again, that's from 4 to 9. Okay. And again, if we multiply the numerator and denominator with the reciprocal, so if we multiply this by 2 over 3 and this by 2 over 3, we will end up with 3 times 2 over 3, move that up, x to the 3/2 minus 4, multiply both the numerator and denominator by 2, times x to the 1/2 from 4 to 9. Okay, so this 3 and this 3 will cancel each other out. So we end up with 2, and instead of x to the 3/2 power, we can rewrite that as square root of x to the 3rd power minus 4 times 2 is 8, 8 x to the 1/2, we can just make that square root of x. And clean that up a little bit. And that's from 4 to 9. All right, so now we just go ahead and plug in our values. So we plug in our 9 into both of those terms. So that's going to equal 2 times square root of 9 to the 3rd minus 8 times square root of 9 minus, now we plug in our a value, 2 times square root of 4 to the third power minus 8 times square root of 4. Okay, so if we simplify each one of those terms, we have 2 times square root of 9 is 3, so 3 to the third power is 27, minus square root of 9 is 3, so 8 times 3 is 24, minus square root of 4 is 2, 2 to the third power is 8, you have 2 times 8, minus square root of 4 is 2, 8 times 2 is 16, Alright, so if you notice here, 2 times 27 is 54, minus 24, minus 2 times 8 is 16, so you have 16 minus 16, which is 0, so that's minus 0. So 54 minus 24 is equal to 30. Okay, and that is our answer. All right. So if you are still writing, feel free to press pause, but we're going to go ahead and move on to our next example. All right, so let's say, for example, we want to evaluate the integral from 0 to pi over 4 of secant squared x with respect to x. All right, so for this one, you want to remember the integral of secant squared x with respect to x is tangent of x plus c. Okay, but since we're using the fundamental theorem, we don't need the plus c. Okay, so that means the integral from 0 to pi over 4 of secant squared of x with respect to x, since the integral of secant squared x is tangent x, that's going to equal tangent x from 0 to pi over 4, since we're not using the plus c. All right, so we're going to plug in our b value, so that's going to equal tangent pi over 4 minus, now we plug in our a value, tangent of 0. Okay, so tangent of pi over 4 is equal to 1 minus tangent of 0, which is 0. So your answer is 1. Okay, so you can use the fundamental theorem with any function at all. All right, you can use it with trig functions, you can use it with basic functions, whichever one you need. All right. So if you are, again, still writing, feel free to press pause. But now we're going to look at the integrals that involve absolute values. All right. Integrals of absolute values. Of absolute values. All right, so let's say, for example, we wanted to evaluate the integral from 0 to 2 of the absolute value of 2x minus 1 with respect to x. All right, so in order to integrate an absolute value, you have to remember the definition of an absolute value. Okay, so if you have the absolute value of some value, we'll say x, then that's going to equal either x when x is greater than or equal to 0, or it's going to equal negative x when x is less than 0. Okay, so let's say, for example, you have x equals 3. The absolute value of 3 is going to equal 3 when x is positive. Okay, so what about the absolute value of negative 3? The absolute value of negative 3, since that's less than 0, the absolute value of negative 3 is going to equal the negative of negative 3. So technically it's going to be negative 1 times negative 3, which is positive 3. So that's why it equals x when it's positive and a negative x when it's negative, less than 0. Okay, so using this same format, the absolute value of 2x minus 1 is going to equal 2x minus 1 when x, and it's not greater than or equal to 0. Quick note here, 2x minus 1 equals 0 when x is equal to 1/2. Okay, so to find where that value equals 0, that means it's going to be x is greater than or equal to that 1/2. Okay, so you're not going to just plug in 0. You're going to find out when that value under here is greater than or equal to 0. So in that case, it will be 1/2. And then it's going to be a negative of whatever's in here, or the negative of 2x minus 1 when x is less than 1/2. Okay, so you want to make sure you don't skip that step. You don't want to just go on autopilot and start plugging in 0, because that wouldn't work for this one. Okay, it has to be when that function is greater than or equal to 0. Okay, and that only happens when x is greater than or equal to 1/2. Okay, now since we have two different functions, we have the positive and the negative, we have to remember that since the integral from a to b of f of x with respect to x, remember we can break that up as the integral from a to c, plus we can pick it up right back at that c and continue on to b. Okay, so that's what we're going to do here. Okay, so that means the integral from 0 to 2 of the absolute value of 2x minus 1 with respect to x is going to equal the integral. Remember, we're going from 0, from 0, but we're stopping at 1/2. So from 0 to 1/2, we're going to use the negative 2x minus 1 with respect to x, plus then greater than 1/2, but we're stopping at 2, plus the integral from 1/2 to 2 of 2x minus 1 with respect to x. Okay, sorry about the shadow. The sun decided to pop up behind me. All right. So if we go ahead and distribute that negative, then that means all we have to do, let me kind of get out the light there. You have negative 2x. So the integral of negative 2x is just x squared over 2. So you have the negative 2 and the 2 in the denominator cancel out. So it ends up being negative x squared. And if you distribute this one, you get positive 1. So the integral of positive 1 is just x. And that's from 0 to 1/2. Okay. Plus, now we get the integral of 2x. Remember, that's x squared over 2. And the 2's will cancel out, so that just becomes x squared. Minus the integral of 1, which is just x. And that's from 1/2 to 2. Alright, so now it's starting to kind of take shape. Alright, move that up. Alright, so it's equal to, remember we plug in our b here. So that's negative 1/2 squared plus 1/2 minus, now we plug in our 0, that's just 0 plus 0. Okay, so plus, plug in our 2. So you have 2 squared minus 2 minus, now we plug in our 1/2. 1/2 squared minus 1/2. Okay, so we apply the fundamental theorem here, and we apply the fundamental theorem here. Okay, so this is going to equal negative 1/2 squared. Remember, the negative is on the outside. So the 1/2 is the only thing being squared. So that's like negative 1 times 1/2 squared. Okay, so that's going to end up being negative 1/4 plus 1/2. Okay, then 0 plus 0 is just 0, so we can leave that alone. So plus 4 minus 2 minus 1/4 minus 1/2. Okay, so by the time you get done combining like terms and simplifying and everything else, you end up with the answer of 5/2. Oops, sorry about that. Okay, so that would be your final answer after all of the simplification and everything else. All right. So if you are still writing, feel free to press pause, but we're going to go ahead and move on to our next example. Okay, so let's say, for example, you wanted to evaluate the integral from 0 to 3 of the absolute value of x squared minus 4 with respect to x. All right, so for this one, what I want you to do is go ahead and press pause and try to solve this one on your own. All right, so I'm assuming you've pressed pause and you've already worked this one out. So let's go ahead and verify your answer. Okay, now just like before, on the previous example, you want to note that x squared minus 4 equals 0 when x equals negative 2 and x equals 2. Okay, all you do is you add 4 to both sides, square root both sides, and you get plus or minus 2. Okay. Now the thing about this is our interval is only from 0 to 3. Okay, what does that mean? That means that x equals negative 2 is not used. Okay, we can't use x equals negative 2 because it's not between 0 and 3. We can use this one, x equals 2, because it lies between 0 and 3. So that x equals negative 2 goes away. Okay, so using our absolute value definition again, the absolute value of x squared minus 4 is equal to x squared minus 4 when x is greater than or equal to 2, or negative x squared minus 4 when x is less than 2. All right, so now we can go ahead and set this up as an integral. So the integral from 0 to 3 of the absolute value of x squared minus 4 with respect to x is equal to the integral from 0 to 2, because remember that's when x is less than 2, of negative x squared minus 4 with respect to x, plus we pick it up and we go from 2 to 3 because x is greater than 2, but we only stop at 3. So the integral from 2 to 3 of x squared minus 4 with respect to x, because when it's larger than 2, we just use the x squared minus 4. When it's less than 2, we use the negative x squared minus 4. All right, so if we go ahead and distribute that negative, integral from 0 to 2, we have negative x squared plus 4, or we can make it 4 minus x squared with respect to x. Okay, so all I did was, just to make sure I didn't lose anyone, negative x squared minus 4. We distributed that, so that became negative x squared plus 4, which I just rewrote it as 4 minus x squared. Okay, so that's how that turned into that. Okay, so plus the integral from 2 to 3 of x squared minus 4 with respect to x. Okay, so if we go ahead and integrate 4, we just end up with 4x. And if we integrate x squared, we have x to the third over 3. Or we can write it as 1/3 x to the third. And that's from 0 to 2. Okay, so plus, if we integrate x squared, we get x to the third over 3, or 1/3, doesn't matter how you write it, x to the third over 3. So you can write it this way or this way, same thing. Whichever one's more convenient for you. Okay, so minus the integral of 4 is just 4x, so minus 4x, and that's from 2 to 3. Okay, so now we go ahead and solve each one of those. Okay, so that becomes, first we plug in our 2. We move this over just a little bit more to make sure I have enough room. So you have 4 times 2 minus 1/3 times 2 to the third power. Minus, now we plug in our 0, we just get 0 minus 0. Okay, so plus, now we do the same thing to this one. Plug in our 3. So we have 3 to the third over 3 minus 4 times 3. Minus, now we plug in our 2. 2 to the third over 3 minus 4 times 2. Okay, so if we go ahead and simplify those, we will end up with 8 minus 2 to the third is 8, so 8 over 3. And that's 0 minus 0, so that just disappears. Plus, 3 times 3 is 9. 9 times 3 is 27, so you have 27 over 3, which is just 9. So you have 9 minus 4 times 3 is 12. Minus 2 to the third power is 8. So we have 8 over 3 minus 8. Okay, so since we're kind of running out of room, by the time we combine like terms and simplify and everything else, we end up with 23 over 3. as our final answer. All right, so hopefully this made sense, and I will see you on the next video.